we're going to go over the answers to your element, compound, and mixture activity that you guys did the last class. There's a couple things that I want to talk about before I get started into this video and going over the answers. And the first is I didn't really expect a lot of you guys to do 100%, but I also really didn't expect some of you guys to do as bad as you did. And so I'm going to be fully transparent and honest. I am a little disappointed in some of the things that you guys missed, and I want to clear this up. The first thing that I'm really disappointed in is a lot of these are answers that are in your notes that I went over, and people missed them. And when I say people, it wasn't just one or two, there were several people who missed them. And that makes me feel like either one of several things. One, you guys are listening to the lectures, but you're not taking in the information to understand it. And in science, you can't just take it in and then try to regurgitate it. I want you to try to understand why those are what they are. Two, you're blindly copying things down. And again, you're not trying to learn the information. Or three, you're just not watching these lesson videos all the way. And then the last one is you guys didn't use your notes to help you work your way through this homework activity, which you guys have full access to. So I need you to please try to watch these videos more intently with the whole focus on trying to learn. If you don't get something, please make sure you ask. The other thing that I was a little bit disappointed about is that I understand that you could choose more than one option up here, but you can't be an element and a mixture at the same time. You cannot be a compound and a mixture. You cannot be a heterogeneous and a homogeneous mixture at the same time either. And that goes down to this flow chart that we did in class. So for example, is the composition fixed, or does it not change, or can it change? If you put yes, that it's fixed, it stays the same, they're in definite proportions, then you can be an element or a compound. If you said no, then you can be one of these two mixtures. But you can't be an element and a mixture because there's no way for you to be both a fixed composition and a not fixed composition. It's like saying your favorite color is yellow and blue. Like you can't have two of those. If it's your favorite, it's your number one. So down here, when it says, can it be broken down chemically? If you said no, it's an element. If you said yes, if it's a compound, you can't be both of those things. It contradicts each other. So when you are classifying matter, you can only be an element, compound, heterogeneous mixture, or homogeneous mixture. You cannot be two of something. So we can only pick one option here, really. With that being said, let's go ahead and go through this activity. The first one we give you is diamond. And this one was on the trickier side, but I tried to give a little hint here and put a C. Here, a diamond would be considered an element because C actually stands for carbon. Here, air, this was one I was a little disappointed in people about because it was in your notes. We talked about how air is a mixture because it has different levels or different amounts of water in it. So its composition varies. Sometimes it can have a little bit of water vapor, sometimes it can have a lot of water vapor. Sometimes air has a lot of oxygen or a little bit of oxygen in it. And since it all looks the same throughout, this would be considered a homogeneous mixture. Krypton, here is one where I try to give you a little bit of hint. Krypton, Kr, that should indicate that that's a chemical symbol. And we learned that chemical symbols go with elements. It's actually one of our noble gases. It's on the far right of your periodic table. Water. This one I was a little disappointed that people didn't get because we, again, talked about water in class. Water has a chemical formula of H2O. So if we're looking at water, we're going to call that a compound from what we learned in class right now. Now, I will preface it with this. If we were thinking about tap water, that's not completely water. So if you said homogeneous mixture, I'm not going to get upset with you at that because that's a good guess as well. But here we're looking for compounds. Ammonia, this one was a little bit tricky, so I decided to give you a formula. So this should have been, okay, I have NH3, nitrogen and hydrogen are together. That's a formula, two elements together. And we learned that formulas go with compounds. So again, here we're piecing the information that we've learned together in class. Wood. Wood, that one's on a trickier side. I'm not given a symbol, I'm not given a formula. So wood, if you look at it, it looks like a bunch of different pieces together. And so we're going to say that's a mixture, and it's a heterogeneous mixture because you can see the different parts of wood. You can see the bark versus the inside. In terms of dry ice, this is hands down the hardest one I put. If you miss this one, I do not feel bad. Do not feel bad at all. Dry ice is actually just frozen carbon dioxide. So it is CO2, and that's actually a compound. I didn't really expect anybody to get that one, but I was kind of curious if anyone would. So again, dry ice is just CO2, carbon and two oxygen, and it's been frozen. Sugar. This was one I was a little bit disappointed about because this one has been in your notes. Sugar is a formula of C12H22O11. We talked about the formula for sugar in your notes, and we talked about how that was a compound. So sugar is 100% a compound that we talked about. Sulfuric acid, this one was a little bit trickier, but what should have given it away is this H2SO4 right here. Again, we talked about how chemical formulas are always going to go with compounds. So sulfuric acid has hydrogen, sulfur, and oxygen in it. Cesium, this one was a little bit trickier. Cesium is actually an element. Its chemical symbol is Cs. It's in group 1 on the periodic table, all the way on the very bottom, right above francium. And so this is actually an element. You can find it on the periodic table. Next one is methanol. Again, didn't really expect you to get methanol, but what should have given it away if you were piecing together and learning things in our class is here we have a formula. Formulas always go with a compound. So here we know methanol is made up of carbon, hydrogen, and oxygen. Salt water. Salt water, this one we did talk about in class. So again, this was one I was really surprised because we talked about ocean water and salt water. This is considered a homogeneous mixture because you are mixing together salt, which is a compound, and water, which is a compound, and you're mixing them. Salt still retains its taste and its own properties when you mix them, but it all looks blended together because it dissolves. So it's considered a homogeneous mixture. The next one is bronze. If you are in my second hour chemistry class, I am still, again, surprised that so many got this wrong because I wrote this on the board for you guys, and we talked about how it's made up of copper and tin. And so we talked about that being a mixture. This is a homogeneous mixture because when you look at bronze, it all looks the same. Sodium bicarbonate, this one's harder. I did not expect people to get this one, and there's really not really a hint for this, except for it sounds like sodium, carbonate. It sounds like some elements together. So if you had put an element or any of these, I would not feel bad. This one's actually a compound, though. So sodium bicarbonate is a compound. Its formula is NaHCO3. Milk and cereal. This one, if you mix those two together, that's a mixture, and that's heterogeneous because you can tell the difference between the milk and the cereal. The next one is salt. This is one I was a little bit sad that a lot of people missed because we did talk about how salt is continuously a compound. Salt has a formula of NaCl. Gasoline, I was extremely disappointed on this one. We mentioned this one, it was in your notes. One of the things to ask yourself if it's a mixture is, are there different varieties of it? Because if there are, that means the composition varies, and that automatically means it's a mixture. Now, it's going to be a homogeneous mixture because when you look at gasoline, it all looks the same and you can't tell the difference between the parts. So this one's a homogeneous mixture and it was in your notes. Next one is lead. This one was a little bit trickier because I didn't give you the symbol for it. But if you've looked at a periodic table, lead is actually an element. Its symbol is Pb. Garbage. Everyone laughed when they saw this one, but it's not an element. It's not a compound. Garbage is definitely a mixture of a bunch of things that you throw away, and you can tell the difference between the things, so it's heterogeneous. Ink. This one I did not expect anyone to get. Do not feel bad if you didn't get this. A lot of people want to think that ink is a compound, but ink is actually a mixture. And that's when you ask yourself, are there different kinds of it? Yes, there are different colors of ink. And so they're just a mixture of all these different colors, but it all looks the same when it's in a pen or a marker. So it's a homogeneous mixture. But you can actually use chromatography to separate the different colors in the ink. The next one is arsenic. This one was a little bit trickier because I didn't actually give you the symbol, but this is an element. It's on the periodic table. So if you guys would have looked at that, it helps you know and helps eliminate some of the elements that are part of this. The next one is pizza. This one most people pretty got. It's not an element. It's not a compound. It's one of the mixtures because you can see that we have cheese and crust and pasta sauce and pepperoni or whatever you put on your pizzas all mixed together. And since we can see those separate parts, this is considered a heterogeneous mixture. Concrete is next. This one's a little bit trickier. Some people put compound, and that's actually a pretty good guess. But concrete's one of those things that it's mixed together. So if you've ever seen concrete being mixed in a mixer, I've watched Bob the Builder when I was little, so it's funny. This is actually harder to tell. Concrete, if you actually look close enough, you can see the different parts of it. So concrete's actually a heterogeneous mixture. You can see the rocks that are part of it and the sand and the pebbles. So since you can see the different parts, it's a heterogeneous. The next one is mercury. So here we are talking about the element, not the car. Mercury is one of our only two liquid elements on our periodic table. Its symbol is Hg. And to round us out, we have T. Some people like to put T as a compound. That is a very good guess. I really didn't expect a lot of people to get T. T is actually going to be a homogeneous mixture if it is like bottled tea that you get at the store. And that's what I was kind of going for. So if you hit homogeneous, that's what I was looking for. If you put heterogeneous, I wouldn't necessarily mark you wrong in the end because some people do leave tea leaves and stuff in their tea so you can see those different parts of it. But if we're talking about straight tea that you're trying to get, let's say at a restaurant, we're going to call it a homogeneous mixture. It's all mixed together and you can't tell the difference between the tea and the water. Okay. So that's kind of the end of this review activity. If you guys are actually watching this video, like I told you guys to watch it all the way through, there is going to be a quiz over these 25 compounds next week. I'm going to give you 10 of these 25, and you are going to have to tell me if it's an element, compound, or mixture. So hopefully you guys listen to the video, you listen to the explanation of how we got the answers, and you guys are ready for the quiz next week.